Hello, in this video I want to explain how you can set up an SAP HANA disaster recovery solution across different Azure regions using Azure NetApp Files. The data replication technology called cross-region replication is based on efficient block delta replication on the storage layer. The video takes around 20 minutes and is divided into 5 sections. I'll briefly explain the environment and the steps executed in the 5 video parts in the next 5 slides. After that, a recorded lab demo will be used to go through the different configurations and use cases. In our lab setup, we are using an SAP HANA MDC system with a single tenant using Azure NetApp Files as the underlying storage. The HANA system is deployed in the Azure region East US, and we are going to set up a disaster recovery solution in Azure region West US. The HANA system is using 3 volumes: the data, the shared, and the log volume. The log backup is configured to be stored in a separate volume. HANA database backups are configured using the Microsoft ACAC Snap tool, which leverages Azure NetApp Files snapshot technology to provide application-consistent snapshot backups of the HANA database. These application-consistent snapshot backups are crucial for the DR solutions since they will be used to recover the HANA database at the DR site. The setup of the source system will be described in the first part of the video. As a next step, ANF cross-region replication is configured to replicate the HANA volumes to the DR site in Azure region West US. The replication will be configured for the HANA data, the shared, and the log backup volume. Recovery at the DR site is done by a forward recovery of the HANA database using the replicated log backups. Therefore, the RPO is defined by the replication frequency of the log backups. In our lab setup, the log backups are replicated once per hour. The minimal schedule supported by ANF cross-region replication is every 10 minutes. When cross-region replication is configured, all the application-consistent snapshot backups will also be available at the DR site and can be used for recovery. Most of the required configuration steps at the DR target system can be prepared and will therefore accelerate the failover in case of a disaster. In addition, the failover process can be tested using the same target system without breaking the replication and therefore without influencing RTO and RPO. In our lab setup, we use the plain /for-SAP installation at the target system. Linux kernel parameter configuration has been done according to SAP HANA and ANF best practices. In order to start an HANA system using the volumes from a source system, the hostname of the target system must be the same as the source system. The IP address can be different. In our simplified lab setup, we reconfigured the local hostname of the target system. In reality, the hostname switch will be typically done by changing a central DNS entry. The HANA users and groups must be configured at the target system using the same IDs as at the source system. Since the HANA log volume is not part of the replication, a separate log volume must be provisioned for the target system. Since we will always execute a clear log operation during recovery, we only need an empty log volume with the corresponding HTTP subdirectories. And finally, the mount points for the data and shared volume will be created. Since we know the volume names at the DR site, we will also prepare the required FSTab files to mount the volumes in case of a disaster. We have 2 different FSTab files, one for DR testing and another one for DR failover. The target host that we have prepared will now be used for disaster recovery testing and disaster recovery failover in the next 2 sections. As mentioned before, disaster recovery testing can be done without breaking the replication and therefore without influencing RTO and RPO. Disaster recovery testing is done by creating new volumes based on snapshots available at the replicated volumes. These volumes will then be mounted at the prepared target system, followed by a recovery of the HANA database using the replicated log backups. The DR testing is identical to the DR failover workflow. The only difference is that testing is done using clones of the replicated volumes, while with a real DR failover, the replication will be broken off and the target volumes will be attached to the target system. The last section of the video will show a DR failover workflow where the same target system will be used as for the DR failover. With a real DR failover, the volume replication will be broken and the target volumes will be mounted to the target system. Recovery of the HANA database is done in the same way as with DR testing. With that, let's start the demo, which should be self-explanatory, so I'll stop talking.